Now we are solving question number 6 of this paper for mechanics. 9709 is the code. Particle P moves in a straight line starting from O. The velocity of P measured in meters per second at the time t seconds after leaving O is given by V is equal to 0.6 t minus 0.03 t square. Part 1. Verify that when t is equal to 5, the particle is 6.25 meter from O. Find the acceleration of that particle at this instant. Part 2. Find the value of t at which the particle is traveling at half of its speed, maximum velocity. So these are the two parts of this question. So first of all, we have to show that at t is equal to 5, its displacement is 6.25 meter. We know from this equation that displacement s is the integration of velocity with respect to that equation there. So we will have this acceleration, s there is equal to integration of 0.6 t minus 0.03 t square dt. So this will become s is equal to 0.6 t square over 2 minus 0.03 t cube over 3 plus constant of integration a there. So s is equal to 0.3 t square minus 0.01 t cube plus constant of integration a there. Since the particle is starting at O there, so its time is equal to 0 and displacement is equal to 0. So if displacement is equal to 0 and time is equal to 0, then A will be equal to 0. So now we put S is equal to 0.3 t square minus 0.01 t cube is the equation of that displacement there. Now we have to show that at t is equal to 5. So distance at t is equal to 5 is equal to 0.3 into 5 square minus 0.01 into 5 cube, and that thing is equal to 25 into 0.3, 75. So 7.5 minus 0.01 into 5 cube is 125. So that value, after doing the calculation, it is equal to 6.25 meter, which we have to show in the beginning of this question number 1 there. Then they ask that find the acceleration of that particle there. We know that acceleration is basically equal to differentiation of velocity. So differentiation of velocity is equal to 0.6 into 1 minus 0.03 into t square derivative is 2t. So this will become 0.6 minus 0.06 t there, and that is the acceleration of that particle there. But so they have not mentioned the time there, so we are just going to find it out at 0.6 minus 0.06 t there. Since they have mentioned the same time t is equal to 5 for that, so that acceleration will be equal to 0.6 minus 0.06 into 5 So that acceleration is 0.6 minus 0.3, that is equal to 0.3 meters per second square is the acceleration of this particle from that point there. Now the second part is second part, you have to find out the time there when it has covered the half of its maximum velocity. So we know that for maximum velocity, you put acceleration equal to 0. Already we have calculated the acceleration of this particle is equal to 0.6 minus 0.06 t. So that thing is equal to 0. So 0.6 is equal to 0.06 t there. So t is equal to 0.6 over 0.06. That thing is equal to 10 seconds. Now the velocity at that 10 seconds will be equal to 0.6 into 10 minus 0.03 into 10 square. So that thing is equal to 6 minus 0.03 into 100, or that thing is equal to 3 meters per second square. This is the maximum velocity at that point. But they said half of that velocity there. So half of v is equal to 3 divided by 2 is equal to 0.5. Sorry, 1.5. Now you have to calculate the time for that velocity there. So it is equal to 1.5. So it is half of that, which is equal to 3 now. Now we are going to calculate the time for that part there. Since velocity is equal to 0.6 t, minus 0.03 t square, and that thing is equal to half of that, that is 1.5. So you divide it by 10. 10 is going to multiply by this, so this will become 60 minus 0.5, sorry, minus 0.3 t square is equal to 15. So this equation will become, if we even divided by this value by 10 there, so it should be equal to 60t minus 3t square is equal to 150, or 3t square minus 60t plus 150 is equal to 0. Take 3 as common there. So t square minus 20t plus 50 is equal to 0. Now we can apply the quadratic formula this. So it should be 20 plus minus 20 square minus 4 into 1 into 50 divided by 2 into 1. So that value is being calculated there equivalent to 2.93 seconds or 17.07 seconds. So this is when it's half of the speed of that, then you are going to find out the time for this question there.